I'm rather pleased I was able to fix my oscilloscope. The attenuator in channel 1 had gone faulty, and the rest of the video is about how I went about repairing that. Now, rather than sort of drag you endlessly through a long video, just to get a few points that you might not be sure about, especially for those of you out there that have got plenty of experience on these things, I wouldn't like you to make the same mistakes I made, and I did make a big lulu of a mistake, and besides a couple of others on the way, and I'll perhaps mention them as I go along. Right, without further ado, let's get on with our spoiler. To get the case apart, you need to first remove this back of the oscilloscope. It's held in by 6 screws. There's 1, 2, 3, 4, 5, and up the top here somewhere 6. Once you remove those, a bit of plastic just pulls off quite easily, no problem. Then you slide the case and handle off, and you're left with your oscilloscope, the bare bones of your oscilloscope. And on the top you will see there's a screening plate right over the top that needs to be removed. You may think that's a bit odd as the attenuators are down the bottom, but I'll come to that in a minute. That is, the screening plate is held in by 5 screws on the top and 2 on the side. I believe there's 1 on that side and 1 on the other, on the opposite corner on that side there, on the back of it. You remove that, and if you look directly down, there are 2 holes. In those holes will be the screws that hold, or one of the screws that hold the attenuator module to the circuit board. Now, the attenuator module actually plugs in, but it's held in place by 4 screws. Now those 4 screws, there's 2 in the front of the attenuator, which are obviously behind this front panel. 1 there, 1 there, and there's another screw somewhere just about there, and the one that we're talking about you'll get access by after you've removed the plate. Now we got that far, and here's where I made a big mistake that I wish I'd never done, and I hope that you don't make the same mistake. We got to remove the front panel, and I started just removing all these knobs, because once they're removed, I was thinking that the panel would just slide off, and in fact you don't have to do any of that. You do have to remove these knobs, 1, 2, 3, 4. I've got 1 missing. There's always been 1 missing even when I bought it, and I bought it second hand. There's a trim strip along the front here. Now once you remove those for what you call them, knobs, there's a trim strip along here, and there's I think 4 screws underneath there from memory. 1, 2, 3, 4. Then underneath, I'll show you them underneath because they're visible. There are another 4 screws, 1 there, 1 there, 1 there, and 1 there. Now at this point you can remove this is a plastic frame, comes away, that holds the screen glass and everything too, so all that comes away, and this front panel is no bigger than that, and you just sort of prise it away from the edge with all these knobs intact, and it just slides off of the terminals of the attenuators, because it's all on a ribbon cable inside, so that gives you that degree of flexibility, and you move that away, then you can get the screw that's in there, the screw that's there, and the screw that's underneath the base. At that point your attenuator becomes absolutely unpluggable, except, and this is important, really important, it's soldered in on 2 points, and it's crucial, absolutely crucial, that you take ultimate sort of care over unsoldering these, and you'll see them when you get there. But this one is soldered on, and this point here is soldered on. This one you've got easy access to, so you can sort of pull it away easy enough. It's sort of blobbed on it, so just get the brake and don't try to flex this about, whatever you do. Equally well, the same with this little one at the bottom here. Once you've got it hot and broken, you know, you sort of feel that you've got a gap, then you can pull the attenuator out. And not until that point. There's a big danger of breaking the attenuator plate on which all the components are sort of built on. It's a ceramic plate, and all the components are built on there as like a thin film sort of arrangement over there. I will make a separate video sometime in the future, so don't hold your breath, about the insides of that attenuator. And if, like me, you find that it's damaged inside, there's very little chance that you're actually going to be able to repair it. I did hope, I had my fingers crossed until one point in the when I was sort of analysing the fault to start with. I got to a point I went, oh no, it's broken, and at that point I knew I had to replace the attenuator. Up to then I was hoping that it just may have been dirty contacts on the relays that were inside there. Right guys, from here on you're on your own. You can watch the rest of the video if you like. I hope that helps a few of you. If you ever come across this sort of problem with the Tektronix 2445A oscilloscope. It's a bit of an old lady now, and but it's a quality scope, and I hope it sees me out. So there you go. It's now 24 hours since I last looked at the problem, and I've got an inkling of an idea, but to prove my point I need to map all the responses that I'm getting on channel 1, and it's going to be a rather laborious task of going through it all, and I don't want you all to suffer, but I'll leave the video camera running and speed it up when I edit it. Right, there's 2 millivolts per division. We can't get our line up, it's being driven off the screen somewhere. So I'll make a note of that. Okay, go down to ground setting is the next one, and it looks like we've got an offset of 47.6 millivolts negative. And next setting down is the DC setting. Oh, again we can't get the sweep up. I'm not going to worry about that, getting the line up, because it's just not going to work for us. DC setting is minus 47.6. Ground again is minus 47.6. This time we're going to go 50 ohms termination, and we do get a difference. It's minus 0.4 millivolts. I'll make a note about the baseline coming up now. We can sort of adjust it. And that was the 2 millivolt per division setting. I'll revert back to the AC setting. Next range, 5 millivolts per division. and again AC, no reading. Ground, this time it's minus 119.0 millivolts, and if you notice, that's actually 2.5 times the last reading. Yeah, definitely our last one. Minus 119.0 volts. Minus 119.0 volts. Minus 119.0 volts. Minus 119.0 volts. AC is blank. Well, I've just completed going through all these switches, and frankly I'm more confused than ever, but I do really believe it's a HR problem. That's high resistance, a poor connection somewhere in the relay switching. It's beginning to look more like that on what I'm seeing on the bit of paper I've been scribbling down all the notes on. I'll draw it up into a proper table and we'll come back to that, and we'll look at that in conjunction with the operation of the relays in relationship to the circuit diagram. This is the attenuator circuit for the channel 1 input of Tektronix Oscilloscope 2445A, taken from their service manual. And don't believe everything you see here. It's a little bit more complex inside than this basic diagram, and parts of this diagram don't make any sense, particularly this relay contact here and that relay contact here do not go down directly to earth as shown in this diagram. And when we open one up, I shall show you how this functions. We're getting some really odd results. We're not putting any input signal in, but we are getting sort of we're able to sort of measure voltages, and I'll run through all the settings. So with no attenuator switched in, the path on the DC setting goes through this relay contact, up through here, through this relay contact, which sort of then shorts out this attenuator, through this relay contact closed, that shorts out this attenuator, and we go to the 1 mega ohm resistor, which goes off to the preamplifier. Now on that through range, the preamplifier deals with the 2 millivolts, 5 millivolts, 10, 20 and 50 millivolts per division settings, so it just sort of amplifies them up. You can see that the ground, DC and ground settings all show a sort of standing voltage on them. They are described in the operating manual, because these readings are actually taken off the screen of the oscilloscope. They are described as the trigger point voltage, They're all negative, which is a bit odd, and they are all multiples, believe it or not, of 23.8 millivolts. So all these readings, as I say, are multiples of 23.8 millivolts, and I suspect that's what we've actually got sitting on the input to the preamplifier. The fifth, and it's of fairly high impedance, because when we switch to the 50 ohm range, and that's this little one clamps on, so we've got this line through here, through this route down here, and the voltage being developed to that point is now clamped via 50 ohms instead of 1 meg ohm. It may be that this earth is problematic, or that we've got a problematic earth somewhere there. We'll go to range 2, which is switching in one of the attenuators, and we'll take this one for example. I'm not sure which one switches in, but we'll take this one. And things begin to start to work. If we put a signal on the input, we do see deflections as appropriate on the oscilloscope, and without no input we seem to have this sort of reading on the screen, but we're able to get our sort of cursor sits midway, not our cursor, our trace sits midway across the graticals of the screen, okay, with no problems. However, when we switch through to the ground settings, again we get a sort of weird results, and I'll look at that again sometime because something just popped into my mind. But as you see, there are multiples again of 23.8 millivolts, which is strange. When we go to the 50 ohm setting, we now clamp it down again, and I'm beginning to think that this earth is missing, because that would sort of explain away the 2.38 volts, would explain these voltages appearing, and will being clamped this time once we go to 50 ohm setting. There must also be some clamping action being derived by the attenuator itself, because the attenuator is set and it looks like it goes down to earth, but it doesn't go directly. The circuit is a little bit more complex, not a little bit, but quite a lot more complex than what's shown here. And I would have issues with Tektronix for producing this diagram, because you couldn't use it for fault finding. It's just a stylized image of what is going on in the attenuator. If you think you've got an attenuator fault, the best thing to do is to swap it out. Right, now we'll go to the third range, which again is really weird. This is where we've got two attenuators switched in, so the circuit for the DC would go through there, through this one, down to there, and whatever's appearing there gets amplified by the preamplifier. And here we get all the same readings. Doesn't matter what we do, we get all the same readings, which looks like you've got a sort of a break somewhere here, a disconnection somewhere in one of the attenuators. And because we've been using that one for the one range, we'll say we've got a break here, and that's rather sort of odd. And even when we put the 50 ohms on, it's sort of, this is why we're still not getting anything, because the voltage that sort of the preamplifier is seeing is somewhere this side of the attenuator, and not the input side of the attenuator. Now, how does the ground setting work? Well, I think that the ground setting is no more than the 50 ohm relay through this contact, but in addition I believe that the relay here is operated such that this contact is open. You wouldn't want to ground if you had a probe connected, say, to a power rail or something that you was testing voltage of, you wouldn't want the power rail to sort of go through down to ground like that. You would end up could end up with quite high currents flow. Why 50 ohm earth? A 50 ohm earth, the input impedance of this attenuator network is meant to be 1 mega ohms, and that for argument's sake, and 50 will shunt it by, I think, about, it's 200,000 to 1, so you know, it's as near as earth as damn it. So I think that's what's going on. I can't see how it would work otherwise. And although when you're going from ranges 1 to 2 volts to 5 volts, you don't hear any relays click, you certainly hear the relays click when you go from your AC to your ground, to your DC, to your ground, and to your 50 ohms. Right, I think I've said it all. The only thing I can do really now is to sort of take the attenuator out and have a look at it. I'm not happy. I think that this earth may be missing, or poor earth there, and these contacts are not actually doing exactly what they're showing in this diagram. I think that's all, other than to say that I think one of the attenuators is broken, and that there's a disconnection through the attenuator. And lastly, I would say, if the attenuator proves to be functioning okay and all the contacts are doing what they should do and there isn't a break or anything, then we'll have to think again. And it could be that, well, I don't know. I really don't know. It's difficult to sort of be definitive about this. Something's wrong. I'm hoping that it's nothing to do with the drive to the relay or further back in the sort of circuit diagram, because we'll never be able to repair it, because the components, most of the components, won't be available anymore. Right, I think I've waffled enough. Let's shut up. The time's come now to open the oscilloscope, because I've gone about as far as I can in trying to sort of analyse what the problem is, and I think I've got an earthing fault on the channel 1, and I'm not really that well versed in interpreting the circuit diagram that compiles the attenuators in channel 1. So next thing to do is really take it apart and have a look and plumb around and see what we can find. We've got a soft surface. I'm going to be twisting and turning and taking screws out, and this surface, just said it was soft. That's hard. Things will roll around, so I'm going to put a towel down on there. Well, hopefully as I take the screws out and stuff, they just, if they drop out, they drop on there. Or anything else drops out, it drops on there, don't roll onto the floor. Be a nightmare, look, trying to find anything on this floor. Right, swing around. The case is a sleeve, and it's held in by 6 screws at the back. Now, to be fair, this is not a repair for the faint of heart, and if it's any of the components, the major components like integrated circuits or anything that's causing the problem, then it's going to be game over. They're not going to be available. And this thing was manufactured in, well, we'll find out in a minute once we get a few screws out. A long time ago. As oscilloscopes go, at its time it was a really good scope. And by my reckoning it's still a really good scope, but it is very old. Not very, very old, very old. we'll find out in a moment. I'll take a look at that. I've got ones. Keep coming. I can remove the back cover and let's see how old it is. Well, I was expecting to be able to see the date, but I think somebody sort of covered over another thing with a sort of test and calibration sort of stickers. Yeah, well, let's say mid-80s, 1980s, so that makes this 40 years old, roughly speaking. Right. Now, it's a sleeve, and I don't know how I'm going to get it off. And this handle's in the way a bit, but it isn't in the way. Right. We'll see what we can do. Anyway, it's coming. I'm going to put that out of the way somewhere. Oh boy, look at that. Look. That's only part of it. And then you've got all this. You've got a CRT tube in there. Yep. And channel 1. This is the offending little beast. And we're going to have to get out. Might need a screwdriver. If anything, it's gone. I mean, game over. The outside chance you might be able to get hold of some of the chips, but the critical ones, no. Stream on. And of course, really it does come down to your skill level now, whether you're confident working on a thing like this. Because frankly, you're going to do more damage than good. Well, they're meant to be a plug-in unit, but of course, you've got to take other things off. And first of all, oh no, the front panel's got to come off. That's a pain, isn't it? How do we start? Interestingly, it says on these things, caution, do not wash in water. Need to wash one of these. Put the whole thing in the kitchen sink. Yeah. I think not, but I know what it means. No, I'm going to grunch that. Alright. Need a proper fitting screwdriver for that one. That screwdriver's not the right one. And alright, swing her over a minute and before we wander off to get more tools. We'll find out what's on this side. Now, channel 1 is straight down there, and guess what? You can't see it. You can't see the back of it literally can't see the back to do anything. Can't do anything to it. It's there's a cover over there, another screening cover. This strip. That came off easy. That's all the screws. Looks like got to take all the knobs off. Oh god, this really is going to be a boring job. It's going to sit here for days, isn't it? It's awful. Well, to get a better view inside there, presumably let's take this off and see what we got. I'm going to end up putting a lot of this back for the evening, I suppose, so I remember where everything goes. Right, that's 3 screws out. What's going on here? That looks like a 4th. That goes over here. Maybe even more than a 4th. Oh, can't see, can you? Oh, bring it over a bit. 4th screw there, which has just dropped out onto the table. So what I said about putting a cloth down was a sensible words. Now all of them had star washers underneath, so I'm presuming there's going to be a star washer dropped out. No, no star washer underneath that nut. These 2 seem to be holding it in, and that is a sort of a clip. Is it a clip? That clip looks like it's got a wedge in it. Oh, it gets worse, doesn't it? Right, well, if we're going to do anything, we're going to have to take it apart. I'm going to settle for... This is more of an inspection, really, than anything. Oh, that came off easy enough. Oh, held there. Still held there, so there's another screw underneath that. And a screw in, and a screw in there, which is, or 2. Oh, wrong. These scopes were, without a shadow of a doubt, Tektronix were the oscilloscopes I have certainly, I don't think from a desire point of view, they were built well. Yeah, okay, they're the same size. No, that's longer, that's shorter. The ones that go on the side, the ones that go on the side seem to be shorter than the ones that go in the back. Let's see if that's free now. Oh, definitely free. Right, I'll swing it back. Oh. This top hole that's in there, there's another little hole there, and inside of that is the screws that hold the back of the channel modules, channel attenuator modules. So there's no need to sort of take anything further apart. We need to sort of get screws in to undo that. Right, that's good news. All of a sudden I went, as I was lifting it, I just noticed that this sort of frame also comes, this is just a frame, so it looks like that frame comes off too. I bet this was an expensive scope when it was made. Unfortunately, the only way to get the channel attenuators is to take the front panel off, and that means removing all these knobs, and oh god, that's going to be tedious. Yeah, it comes out. Even if this video is no use to anybody, and it will be of use to me when it comes to putting it back again. Right, those screws out. And we'll keep those together. So now keep them together. I'm turning into a bit of a nightmare, this job. I hated pulling those off. Hated it. Absolutely hated it. Alright. I always thought I was missing one on, and prove right, okay. I'll lift this up. That's off. What's come off now? Is it? I don't understand that. Oh well. Well, that's pretty damn crude. It don't even fit in there nicely. How does it? Oh. There's a... Oh there. Alright. No. Ah. No need to have taken any of them off. Absolutely no need to have taken any of them off. Oh, what an idiot. Well, there you go. Save yourself the trouble. You don't have to take any of them off to get it out. You just have to take off the surrounding bezel, which means to remove those, and then you can actually just lever that forward. Ah, what a waste. What an idiot. Right. Now, oh, another glass has fallen out, and this time it is glass, not plastic. Put that over there. Now this bar has to be released so that we can pull these out, and we're almost there. What a nuisance. What an idiot. Oh, can't believe I did that. I should have gone with my gut feelings. There. Tragic. Right. Well, this is the point I've got to desolder. There's a sort of a diode that goes down to the PCB. This resistor capacitor network goes to the attenuator, and as it's difficult to get in there, perhaps this end may be the easier one to desolder. Let's get up to temperature. There we go. That's soft. Let's see if we can get in here. It's going to be difficult. Not damaging anything. I was wrong. There's 2 screws, one there, one here, and I'm not sure how many on the back. I just think there's one, but we won't know until we turn it over and have a go at getting it out. And fortunately, I can get this screwdriver on there. I think that's that. And the screw's fallen into the inside. Oh, I managed to get that one out. And wow, I'm getting lots of screws. Hopefully that's going to fall out. Oh, let's take this out while I'm here. It's just in the way. And this strip must go back in place. Must remember to put that back. Let's see if we can get the screw out first. Is it falling out? Falling right through? No. Oh, yeah. Fortunately, that's fallen all the way through. Turn it on the other side. I'm going to revert to another screwdriver for this. I don't think I can get in there. Possibly that one. And cool. Of course we're going to stop recording because we're going to fill the card up in a minute. I think that's the extension bar. Yeah, let's see. Which one's channel 1? Yeah, it's the one. Yeah, it's the one nearest the. It's a wobbly. Right. We've got the screw out. Let's see if it's magnetic. Yeah. Can be difficult to get to. This is okay out. Yeah. Oh, that's shifting it. There's a washer underneath it. A little star washer. No, just a plain washer. Was there one under the other one? Yeah, that's okay. I've got little washers underneath them. Right, there's two. Turn the back again. Alright, turn the side of that thing again. If we can. As we pull it out, hopefully. Get it free. There is another connector, of course. Side connector we haven't pulled out yet. And make it all set up. No, no. I know what might work. I have a whacking great big pair of pliers, not pliers. I got it. Right. Oops. Oh. Didn't have the recorder on when I took it all apart, but it's only 4 screws, and you lift off the cover and juggle the wire around. Be careful you don't bend these pins on the back, because they're very delicate and it's all got to push back in again, so be careful. We can remove the relays by undoing those 2 screws, which we're going to do now. Come out again. So. I'm trying to protect the pins underneath by keeping them off the table. I don't really want to damage the pins. That's the 1 screw. Take out the other screw. Let's see what we got. Oh, I mean, it's evident straight away what the problem is. It's look, it's a broken. Look, guys, it's broken. There's nothing you can do about this. It's literally game over for this thing. I've heard of these things breaking before, never seen one, never thought that was going to be the case with this, but it is, and so it's game over with that. There's an interesting little aside here. I would like to point out that the spark quench circuits that are all across the relay contacts, and that's why you've got all these little components that act as spark quenches. There's also a sort of spark arrestor network here. You can see sort of a little brown staining that goes along there, and I presume it's arced across there at some time. Think of it, I almost think of it like a Jacob's ladder, but you know, I've never seen it before, but that's how I would tend to think of it. Yep, game over for this one. I don't think there's anything I can do to repair it. This is the I did talk about a 1 mega ohm resistor, and I think that's it. Oh, I may be wrong. Going down to earth. Oh well. So I go. What do I do now? Well, I'm very, very lucky, because in my wisdom I sort of anticipated things like this happening, and when I got the chance I bought some pulls from another oscilloscope. So I've got a replacement, and I took it apart to have a look to see how it works, and now, basically speaking, put it together and hope it works. I hope we can get the scope going again, because it really is a good quality scope, or was when it was made, and as some of us prefer to have the old-fashioned CRT when we've got a clean sweep and we can see what's going on, rather than have but it won't be the end of the world if the scope has to go. We'll probably have to replace it with something more modern. A lot of people in the repair business wouldn't use an oscilloscope, got very little need for an oscilloscope, and really it's not the sort of thing you'd jump to. If you're repairing a lot of analog equipment, a scope is probably more useful to you. Well, I certainly think so. And I come from a background where oscilloscope was part of my essential kit. Many oscilloscopes. And a long time ago now. Right. Yeah, let's put the broken bits over to one side. Probably there. There. Put them up there. Might be able to salvage something out of the broken one in case something else breaks again in the future, but let's be honest, I mean, there's no way that we can repair this. I certainly don't think there's any way we can repair it. No space under the relays to there's no space under the relay assemblies to put discrete components. The only way I think that we could recover from this is to see if we could actually build one from scratch, but that's a bit nuts, isn't it? Yeah, that is nuts. It's a nuts idea. No, stupid. There's like a little plate, a little plastic guiding plate, which sort of should help to line the holes up. Oh God, upside down. Let's see if it'll fit in. Huh? I can put that screw in properly. Right. Thought I'd put it in properly. Nope. Done it up. Yep, that one's done up. Right, okay. Let's see if we can get her in. Oh, sort of. I don't believe it. Feels like it's actually going into place, guys. Alright, well done. Now to sort of reattach these things. Oh, well. Caution, do not wash this module in water detergent. That's funny. That is funny. Oh, I'm just lining up the wires. Don't want any. Okay. Where I'm soldering is a sort of a little tweaking pot, like a sort of a capacitor that has to be tweaked when you're calibrating things, calibrating the inputs of these things in service. Now, I've been melting plastic again. Alright, let's see if we can get in there. Job done. Yeah, that's good. I'm pleased about that. Put the screws in loosely to start with, in case we need to line up things. Move that out of the way. That one's in. That one's in. I'll come back and have to tighten those up, but initially let's get that out of our way. Oh dear, these are going to be difficult. Provided it stays on there. Well, that wasn't so bad. Alright, the next screw is got going just down here. Bit awkward, but we'll get there. Look guys, I've just sort of done up the screw that's way down there. I've just done that up. I've done it up tight now. Doing this other one up tight because we'll never get out of them again. And then we'll do the two front panel ones up. And right. Turn the scope over. Put it down. Yeah, as I was saying, I bought it second hand, and when it arrived, channel 1 didn't function. He said that it had been recapped, and what he means by recapping is that there are known capacitors on this particular model that do go 40, and that had been replaced, sort of as a preventative measure. And I've just checked, and it looks like the particular capacitors that go 40 aren't. They're in the power supply. They've probably been changed. I wouldn't know until if I took it apart. I'd have to sort of tell by the soldering. And I suspect that, truthfully speaking, I was sold that this thing that I was sold was perfectly okay when he sold it to me. I wouldn't be surprised if it cracked in transit. I don't hold any grudges against him for that. And it's quite a few years ago that I bought this thing now. And it's quite a few years ago I bought the replacements just in case. And that's the replacement attenuator. I was very, very lucky to get a couple of pulls from somebody who was stripping one down for spares. But as good as this scope is, and it is good, it's had its day. You know, there are better alternatives now out there for people. Right, I'll leave the recorder running because it's more to do with more for my reference as I go along. I seem to have lost the star washer, which I'm not happy about because I don't know where it is. I hope it's not inside the oscilloscope. I'll have to give it a wee bit of a shaking when it gets to a suitable point where I can give it a shaking. Well, I'm just putting in the final screws. It may all be coming apart again because it might not work. Who knows? I haven't tried it yet, and it could be, it could be a disaster. On the other hand, it may be a complete success. I've probably been a little bit overconfident. We'll see what goes on. We got it plugged in. Let's see if anything happens. Oh, got an illumination on the scale, which it goes for a self-diagnostic routine. What's all that? It's all blurred and horrible.